All right, welcome back, AP Econ students. I wanted to do just a brief review here of the perfect competition graphs and show when they're breaking even, long-run equilibrium, or when they are losing money, making money, and then also contrast them with the marketplace. So I want to start right here and draw the traditional picture of perfect competition, the firm. And this is when you first learned about having Mr. DARP. And so if we draw Mr. DARP in here, and he is perfectly elastic, we know that that is going to be marginal revenue, demand, average revenue, and price. And we would say, well, our ATC, long-run equilibrium, is going to hit right there, and our marginal cost curve will come through. And we would have our marginal cost curve, we would have our ATC, and we have Mr. DARP all in long-run equilibrium. Pretend those all hit the same place. We have quantity, and we have our price axis. And when we have this situation, we're in long-run equilibrium, and if you recall, this is a situation where your total revenue is equal to your total costs. And so whatever this quantity is right here, we are bringing in this much money, this rectangle right here, but it is also costing us this much money. And so you have zero economic profit, you have only what's called normal profit. And so when your total revenue is equal to your total costs, that means you have zero economic profit. Actually spell that out. We have zero economic profit, but that's the same as normal profit, because a part of your cost structure is compensating yourself, and you would have that in there. So in the long run, this is what happens in perfect competition. Everything's just chugging along, doing well, and although you have zero economic profit, you are being compensated and everything's going well. And the reason that this is what happens in the long run is because it's so easy for firms to enter and exit the industry when things aren't going well. So this would be your classic long-run equilibrium, perfect competition. Okay. Now I'm going to come over here and I'm going to say, well, what happens what's it look like when you're making money? Well, all that means is Mr. DARP is high, and so or higher than your ATC anyway. So I'm going to draw my ATC right here first, and I'm going to draw my marginal cost curve going through. So there is my marginal cost curve, there's my ATC, but I said Mr. DARP is higher than my ATC. Okay, so there is Mr. DARP. I'm just going to put it that way. All right, now very important, your tattoo, MR is equal to MC, is right there. That is our profit maximization quantity. And you could come all the way down here, and you could call that Q sub PM for profit maximization. This is my quantity axis again, this is my price axis. And this is my total revenue, would be this big rectangle. That's how much money I'm bringing in, but it's costing me money to make this stuff. And so this would be my total costs right here. So total costs is down here, and this would be my profit because this is my total revenue. So all the money I'm bringing in, I get to subtract off my costs, and that's going to give me my profit. So in this situation up here, my total revenue is equal to the sum of my total costs plus my profit. And I'm experiencing economic profit. Now remember, the vertex of the ATC is not in the box. And you always want to make sure you make your ATC. I made this one actually a little bit flat. You want to have a nice quadratic here. The minimum is not in there. Okay, so this would be perfect competition making a profit here. Okay, now the one thing I want to do is come back to this one right here. I want you to notice that your MR equals MC rule still held. And this is why students oftentimes make a mistake. Yes, you're intersecting at the minimum of the ATC, but that's only in the long run. That was a coincidence. It's MR equals MC. That is what gives you your quantity of output. So the most common mistake over here is to think that this is an important place right here, which it's not. Okay, it's actually productively efficient, so that's kind of important, but as far as output goes, it's not. So make sure you don't make that error. Now the other thing that can happen is Mr. DARP is low. And so I'm going to draw my ATC again. And I'm going to bring my marginal cost curve through there. So there's my marginal cost. Here is my ATC. But now I'm going to make Mr. DARP low. So when Mr. DARP is low, we're losing money, lower than my revenue, but MR equals MC still holds, so there it is. So MR equals MC. There's still our quantity of profit maximization, but it's also loss minimization. And I'd say, well, here's how much it's costing us to bring this in. You guys can see how big that cost box is, and here's my revenue, is just this part right here. So this is where I'm losing money. This would be my loss right here, and this right here would be my total revenue. This is all the money I'm bringing in. Whereas up here, my total revenue would be this entire thing. Okay, so on this one, I'm losing money, and so my total revenue, hopefully we can get that so we can see this here, my total costs are actually equal to the total revenue plus how much I'm losing. And that's my total costs, and so they're higher, and therefore I'm losing money. So Mr. DARP breaking even, Mr. DARP is high and making money, Mr. DARP is low and making money, or I'm losing money. Now the other issue is you want to make sure you know where is your AVC curve. Your average variable cost curve is lower than your ATC, but you want to make sure that Mr. DARP is higher than the AVC minimum. So in this situation, if I draw my AVC comes down, I'm going to put it right here. If that's my average variable cost, notice how Mr. DARP is higher than my AVC minimum at the quantity of profit maximization. This means I still stay open even though I'm losing money. Now, if I would have drawn my AVC a little bit higher, I would close. So I'm going to sneak that in here. I want to get rid of this. So this always is a little tricky here to make the picture work out without making a total disaster here. Okay, so now if I draw an AVC and I put it in like right here, you would say, well, look at that. There's my shutdown point. Mr. DARP is below the shutdown point. If it's below the shutdown point, then I'm not opening. Okay? And so your price has to be above the shutdown point to stay open. Okay? So those are those three scenarios, and then we're going to move on to the market contrasting with the firm. Now, the very important part here, the three pictures that are drawn here on the sides, these are the firms and what is going on in their individual business. But when you're in perfect competition, it's always side by side with a market. And so what I want to do is go through the scenarios that would produce these three situations based on what's going on in the market. So frequently, the kind of question you'll get is draw the firm and the market in long-run equilibrium. So the first thing you always have to realize is that the left side, when you contrast these, the left is always the marketplace, and the right is always the firm or the individual company. So sometimes, because it's frequently an agricultural question, the firm is actually a farm. So on the marketplace, this is always just traditional supply and demand. So you could just have a nice supply and demand curve. And you need to know that out of the market supply and demand, that is where Mr. DARP comes from. And so that relationship is very important. So if that is Mr. DARP, that connection is very important. And I'm just going to draw this top one in long-run equilibrium. And I'm basically just going to redraw this graph over here and say, well, if this is in long-run equilibrium, I'm going to have my ATC and my marginal cost curve coming through here. And they would probably have you write Q sub PM profit maximization, something like that. And label all of your axes. And the one thing you want to keep straight also is sometimes they have you write the quantity in the market, and they might call this one actually Q sub M because I'm in the market, and they might actually call this one Q sub F because you're in the firm. That's not an uncommon thing to do. And so even though the market price is the same as the firm's price, they'll have you do that. Okay, so there's long-run equilibrium now side by side. So then how would this situation happen where we had an increase in demand? Well, it could be or sorry, we're making a profit. So let's see, how could this graph actually occur? Well, this graph is going to occur when equilibrium is higher, and this is in the short run before anything gets to adjust. And so the only way you can get this point of intersection higher is if there's an increase in demand for a product or there's a decrease in supply. It's going to pull up Mr. DARP. So I'll do an increase in supply, but I'm going to start with, or increase in demand, but I'm going to start with the original. And I'm going to wind up erasing this, so I'm not going to draw it real, I'm not going to draw Mr. DARP here real clear. So here's where we were, so I'm going to actually just redraw the top. Marginal cost, ATC, okay? And let's pretend in the marketplace there was an increase in demand for a certain product. Now, since we're in perfect competition, let's just say it could be avocados or wheat or corn, just some agricultural product, some crop. There's an increase in demand because it's got health benefits or it's just become popular, taste and preferences. So we had an increase in demand. So here's where we were. Everything was in long-run equilibrium, and now there's an increase in demand. So the increase in demand comes over, and we now have this going on. So here is D prime. Well, the point is, you're supposed to see is that, wow, this just pulled up Mr. DARP. Now, here is my new Mr. DARP, because he increased. So since new Mr. DARP is there, I'm going to get rid of old Mr. DARP. I'm actually going to take it out of the picture. And what you wind up seeing is that you have this one right here now. Now you have a perfect competition making a product, a profit. Here's MR equals MC. I'm going to drop that down. And then here would be my profit box. Again, my vertex is not in the box. Okay, and they would say, oftentimes they say shade in the profit box. Okay, so how do I actually get this to be occurring? Because Mr. DARP was risen. Now remember, this is in the short run, because in the long run, what's going to happen? Firms will enter. Well, firms will enter the market, there'll be an increase in supply, and that's going to pull Mr. DARP back down. Okay? Now, let's do one where we were at equilibrium, but now we wound up losing money for some reason. Well, that can happen for only two reasons also. What's going to wind up giving us a lower point of equilibrium? Well, there's either going to be an increase in supply or a decrease in demand. That's the only thing that's going to happen. So again, let's pretend we were in long-run equilibrium. This is what was going on, and now there was a catalyst going on here that pulled this down. So what we could say is maybe there was an increase in supply or decrease in demand. We could go easy with the, let's say something became unpopular, or there was a crop that wound up having health problems in the consumption, so all of a sudden something became unpopular to consume. And so we had a decrease in demand, so demand went backwards here. Okay, and so what winds up happening is we have a new Mr. DARP, but it's lower. And so now here's Mr. DARP, and we're now losing money. Okay, well now we just created this picture right here. We are now losing money. MR equals MC is right here, and this is going to be now our rectangle. Okay, and this is going to be our loss box. Okay. Now, in all of these situations, you may get a question where it says a company in perfect competition is currently experiencing economic profit. Well, then you just draw this one right away, and you actually just have Mr. DARP high. You don't draw two demand curves. You would just draw the second one here after the demand is shifted. Or a company in perfect competition is currently incurring a loss. Well, then you would just right away draw this one. If they're in long-run equilibrium, you would draw this one. Now, in both of these situations, there is something that would happen next, and they virtually never make you draw this because it makes a very chaotic graph. But if I switch here, I'm going to switch here to red. If you are experiencing economic profit, then eventually what's going to happen is firms will enter, and that would result in an increase in supply, and that would pull Mr. DARP right back down to where he was before. But that's the secondary issue. So this would come back down eventually, because here would be my new equilibrium with my new supply. Now on this one right here, If all of a sudden you're losing money, firms enter. Remember, firms exit, because low barriers to entry and exit. And so on this one, you would say, oh, well, firms are going to exit here. Well, you can see what that does is brings Mr. Dart back up. And then it would just put him right back where he was before. Now, again, they almost never have you draw that because you get too much stuff going on in the graph. But they might have you start with making a profit and then show firms enter, or start losing money and showing firms exit. But they wouldn't have you do two shifts the way I have it here. Okay, so that was just a brief little review on perfect competition graphs. Been a while. Highly recommend you go through and just make a few sketches and just refamiliarize yourself with those. Also, old PowerPoints that have numbers and you can practice. All right. Thanks for watching, guys. We'll see you next time.